Now we might have to make adjustments. The procedure calls for using 2 grams of Benzil. So I've got my creased wax weighing paper here, and we'll go ahead and hit the 0 button. And we'll try to get 2 grams on here. If there are not 2 grams, we'll have to make an adjustment. And remember again, this substance is yellow because it's highly conjugated. And I'll just put all of this on here. It's not 2 grams, but we'll use the same quantity of ethanol and potassium hydroxide and everything in this lab, okay? So let me bring the camera around so you can take a look at the actual mass we're using of the starting Benzil, and there's the yellowish color there, okay? So we're asked to put this into a 25 milliliter round bottom flask, okay? Along with 6 milliliters of ethanol. This serves as the reaction solvent, so it's not too critical. I'll use one of these transfer pipettes to measure that out, okay? It's not a whole lot. The volume is pretty small, as it should be in a 25 milliliter. Now, we want to now add a boiling chip. So I've got these boilizers here, they're called. They're just calcium carbonate. And remember, the purpose of these is to promote even boiling, okay? So that there's no bumping or suddenly vigorous boiling. Okay, so I'll just add a single boiling chip in there. You probably can't see it drop, but it's in there. It's no magic involved. And now we're supposed to heat this up to reflux so that it dissolves. After it's dissolved, we'll add the 45% potassium hydroxide solution. So let me bring you over to the fume hood here. Now the key thing we want to watch out for is making the ground glass joints irreversibly fused to each other, because potassium hydroxide will react with glass. So I've got this grease here, lubrication. It's used in burettes, separatory funnels, things like that. And we'll just put a nice good amount there on the ground glass joint here. And we'll go ahead and put that on there. I like to twist it around a little bit to make sure it's sealed really well. We'll lower this to be in contact with the hot plate, and we'll put this on a nice little 5 setting here, okay? We'll get the water circulating ever so slightly. The solvent here boils at about 80 degrees Celsius, so that's pretty low, and we want to make sure that it does not dry out completely. So that's the purpose of the refluxing and the reflux condenser, is to trap the vapors and return them to the flask. We know that the reaction will be held exactly at 80 degrees Celsius or so during the whole duration of the chemical reaction, because we know the boiling point of ethanol. So I'll go ahead and turn this water recirculator on. Okay. And we got leaking and all that, but that's the best I can do here. So we'll wait for this to dissolve, and then I've got my 45% potassium hydroxide solution ready. If 1 drop of this were to splash into your eyes, you would have about 30 seconds before permanent eye damage were to result. So you need to handle the potassium hydroxide solution very, very carefully. I'm going to add this with this pipette once this has dissolved completely. So I'll fast forward through the dissolving part, and then we'll come back after a bit and get going on the addition. Okay, the solution's not yet boiling, which is fine. We're gonna go ahead now and add the potassium hydroxide to this reaction, okay? And I'm gonna do that through the very top of the reflux condenser. And as you can see, the reaction turns like a black color. That is quite normal. It's kind of scary looking, and it's amazing that we were able to isolate anything white from this afterwards. So it's very dark, kind of yellowish brown black color, like tar or motor oil or something like that. Grease repels water, so the idea here is that none of this potassium hydroxide solution would get into that ground glass joint and cause freezing or fusing of the two glass pieces, okay? So now we reflux this for 15 minutes. I can kind of see it bubbling in there. So let this reflux 15 minutes. We don't need to watch this completely. It's kind of turning a reddish color now. I'll bring you back. I'll fast forward it 15 minutes, okay? Okay, we have the reaction going for 30 minutes. Please make a note in your comments section of your lab report. 30-minute reaction instead of 15, and the reaction mixture has lightened considerably to a light brown, and we now want to cool this. It's very, very hot. When it's cooled so that we can touch it with our hands, then we'll proceed to the next step. So this might take a few minutes, okay? Our reaction mixture is cool to the touch now. We'll go ahead and remove the condenser there. And it's lightened up considerably. It's kind of a pale, well, a lighter brown. I wouldn't call it too pale. And we want to transfer it with a pipette. You see there's grease around the joint here, so we don't want to just pour it out because the ethanol could dissolve some of that grease. So we transfer it to a beaker here, and we're eventually going to place this into an ice bath. Now we could dunk it into an ice bath right now, but it's really hot and it would probably make all the ice melt. So we kind of cool it down to room temperature before we put it into an ice bath. Now my phone's running out of batteries, so I'll just bring you back to what it looks like when it's cooled down to room temperature, and we'll go ahead and put it into an ice bath at that point. All right, so that's what it looks like now, kind of a light brown in color. And we'll let that sit for, I don't know, a few minutes. This is off, it's cool. I'm just leaving it here so you can kind of see it. All right. We've let this sit at room temperature, and crystallization has occurred, and we want to go ahead and put that into an ice bath. Now remember, when you do crystallization, you want to make the crystals form very slowly so that they push impurities outside into the outside solvent. If you dunk this right into ice water, the crystals could form and entrap impurities within the crystalline compound. So in order to get a nice slow recrystallization, you cool to room temperature, then ice. Slower is better in when you do recrystallizations. So we'll let this sit for a few minutes, and then we'll move on to the next step. Hello, here's a the mass of crystals that we have here, it's pretty much a large chunk in there, okay? And we're gonna go ahead and filter this, wash it with some ethanol. So let me take you over to the filtration apparatus system here, and we'll get that going. Now, this is not the final product. Remember, this is the potassium carboxylate that we're isolating. Potassium carboxylate is not sufficiently soluble in ethanol. We will see later it is soluble in hot water. So let's put the side arm on here, get the water circulating. Get our 7 centimeter qualitative filter paper. We're going to wash with a few small portions of ice cold 95% ethanol. I'm going to use some of this to wet the filter paper so that it adheres to the holes in the Buchner funnel. This will make sure that we have adequate suction and the crystals don't go around underneath the filter paper. And now we'll just kind of take this material here, which is a little bit slushy, kind of looks like mud, like a thick kind of mud. So not too free-flowing. I really can't pour this in very well, but we'll just kind of slide it in and scoop it in as best we can. It always amazes me how it goes from a very dark black to a light brown to eventually yellowish and then eventually white after we do the whole workup. So once again, to get this out here, my washes will involve washing the beaker and the spatula here, as well as the crystals inside of this. Okay, so we'll do a few washes of this. Here's 3 milliliters of ice cold ethanol. Pour that in. Get another 3 milliliters. Wash down the sides like so. Okay. And then we'll attempt to spread this out to provide more surface area for the washings. You know, I think I'll turn this off for a second so that the ice cold ethanol has a chance to more better interact with this stuff here. Okay, we'll spread this out. Let's go ahead and put it all in there. Make sure there's no large clumps in there. Alright, we'll turn on the aspirator here to pull down the ethanol. So, didn't do a whole lot of cleaning that up, but again, we want to remove the vast amount of you know, potassium hydroxide and some of this yellow stuff went down. So it's not too critical to let this dry out because again, this is the potassium salt. The next step is to dissolve this in hot boiling water, so we'll get to that step now. So next we want to transfer these tan colored goobers into 60 milliliters of water that's been heated up to about 70 degrees Celsius. I got pulled away for a bit, so it's like 80 degrees, but it's hot enough. So this might take some while to dissolve, so well, that's not plugged in. Put it back over here. So again, the potassium carboxylate salt should be soluble in hot water because it's ionic. Now this is a bit cloudy. Perhaps some material did not fully dissolve, and the procedure says to filter through a cotton plug. And I don't really know how much is in here that we could possibly filter out. But some of it's not dissolving, okay? So I'm going to go ahead and do that now. So the way you do that is you take one of these larger funnels and you just take a cotton ball and you cram it in there, but not too tight because the flow of liquid will be impeded and you won't be able to get the solution to pass through. So I tore the cotton ball in half there, and I'll just, you know, kind of lightly press on it with my pinky to get it in there, okay? And this will be a sufficient funnel filter device to prevent the, you know, solid material from passing through. So while it's still hot, it's pretty hot. Let's see what temperature it is. Well, the thermometer is still warming up, but it's reading 72.9 or so, and it's still rising, so it's sufficiently warm still. And so we'll just gently pour this in. It's pretty hot. Do it up here so you can maybe see it a little better. Sometimes the first pass clogs up some of the larger holes, so I'm going to go ahead and filter this a second time, just by doing exactly what you see there. So whew, that was the stir bar. All right. I'm not sure if you can see that, but there's a kind of a fuzzy brown color there. That's a very small amount of material that's been filtered out. It's still a little cloudy. You know, some of these impurities are probably less than 10 microns or so and can pass on through the filter. So there we are. I'm gonna get a stir bar, a new one, clean one, put it into there, and the procedure tells us to acidify it. So again, the potassium carboxylate is water soluble. When we add hydrochloric acid, it's going to create the neutral carboxylic acid that, because of its neutral structure, is going to precipitate out from this solution. Okay, so let me go ahead and get that started here. So magnetic stir bar, and we'll just use this one here since it's plugged in. Now when we add the hydrochloric acid, we're supposed to vigorously stir it. That's about as much as I can stir it without it misbehaving. So next we want to add 1.3 milliliters of concentrated hydrochloric acid, drop-wise with rapid stirring. So I've got about 1.3 milliliters of the concentrated hydrochloric acid, and we'll add that in. I'm not sure if this is visible on the camera, but every time a drop hits the solution, you see this kind of cloudy white, almost like a precipitation, almost like a titration. So anyways, we want to keep adding this concentrated hydrochloric acid here until it totally precipitates out. Let me check the procedure and see if we're supposed to do this at room temperature. Yes, it's supposed to be warm solution, so here we keep on going, okay? Aside from the clanking solution, I see it changing more white, and I do see precipitate form each time a drop hits that solution. So it's changing more to like a milky milk kind of consistency here. Now definitely you want to do this step in the fume hood because 70 degrees Celsius hot water or ethanol or whatever will evaporate hydrochloric acid. So it's so much precipitate the stir bar stops stirring. Let me check the pH. So here's my pH paper, and here's the scale that we want to look for. We want it to be pH 2, so that's going to be kind of a orange to reddish orange, okay? Right now, it's about pH 5 according to the chart here, so we want to keep adding hydrochloric acid. If possible, we want to, get this stirring vigorously so that the hydrochloric acid doesn't just hit the top of this. Kind of like making a banana milkshake here. Okay, so let me check the pH now. I don't want to add just vast amounts of hydrochloric acid here. It's still showing up maybe pH 3. So pH 3 or pH 2, I would say. We're kind of getting there. Okay, so I'm going to add a few more drops here. So 6 drops more. Let's see what we get. I can see the pH. I'd say it's right around pH 2 and it's staying steady, okay? So let me hold that right there on the scale and you can see it's about pH, between pH 2 and 3, I would say. More like pH 2, 2.5 maybe, I don't know. All right, so I'm gonna go ahead and go to the next step now. The procedure says to do a vacuum filtration and wash with ice cold water. I'm gonna let this cool to room temperature. Actually, I'm just gonna put it right into this ice bath. There's a couple ice cubes left in here. Ice bath here, and we'll let it sit for you know, maybe 20 minutes or so, and then we'll go ahead and do the vacuum filtration and isolate this white product. It's amazing how it turns so white at the very end. So stay tuned. I'll show you the next video in just a bit. Here we are back. We're going to filter our solution from all this water and ethanol, and remember, potassium chloride is a byproduct in here. So once again, we'll get the water going. Since we're washing with water and all of that, we're going to use water to wet the filter paper. At some point we will be doing ice water rinses, and I'll just use the chilled water that comes from this ice bath that we've been using for a while now to cool this various solutions. Okay, we want to make sure the filter paper covers all the holes in that Buchner funnel. Turn the water aspirator up to a nice good rate, and we'll go ahead and pour this milky solution in here. So let's take a look. Pretty gross looking there. It's like yogurt or something. Rinse a few times with ice cold water. Can't really use too much. This is really chilled, and the carboxylic acid is very hydrophobic because of those 2 phenyl groups and all of the hydrogens and carbons that make it nonpolar, so it's not going to be too soluble in here. So we'll just use copious amounts of this to rinse the surface here. All right, so we'll let that air dry about 5 minutes, and then we'll let this sit for a day or so in order for the water to evaporate off the crystals, and then we'll have sufficiently dry sample to analyze in the next step. So that's it for this video.